Hi, welcome back to Miss Rini's class. Assalamualaikum warahmatullahi wabarakatuh. How are you, everyone? Hopefully, you are in a good condition and can enjoy this video. In this video, you will learn about entropy. Let me mention the learning objectives for today. The first one, define the term entropy as the number of possible arrangements of the particle and their energy in a given system. 2. Predict and explain the sign of the entropy changes that occur during a change in state. Example, melting. And then the last one, calculate the entropy change for a reaction, delta S, given the standard entropy S of the reactant and product, where delta S equals to sigma S product minus sigma S reactant. Okay, so before we begin, better for us to recite basmalah together. Bismillahirrahmanirrahim. Okay, let's start. I want to show you a picture and I want you to compare these pictures. So I have two pictures with a different condition. Ta-da! Okay, entropy and your battle. See, chemistry is actually really close to you. Okay, so the last pictures, the condition is a messy bathroom. And then if you see in the bottom part, there is an arrow here. So it means from messy room wants to change, become the tidy room. And then you can also see here, there is some explanation. The left side is in high entropy. And then the right side, the same, we have also arrow in the top part. And then for the tidy bathroom wants to become the messy room. Okay, we have the information related to the entropy directly, but I need you to think, what is the relation between this condition with the entropy? Kindly think first. Okay, so yeah, great everyone. For a messy room, we have to compare how many energy that we need. When messy room will become the tidy room. It's very tired, right? When we want to tidy up all the messy thing in our bathroom. So it's very exhausted and then very tiring. And then, yes, it means from that condition, if we relate it with entropy, it is in high entropy. But for a tidy bedroom into the messy bedroom, it is a spontaneous reaction. We don't need a lot of energy to make all the things messy. Yes, so actually chemistry can explain all of the messy things happen around us. So for example, if your bathroom is very messy and then your mom tell that, your room is very messy. Yes, mom. You can like explain in this bedroom have high entropy. Okay, let's discuss what is entropy actually. Okay, let's see the next slide. The entropy, or the symbol is S, of a given system is the number of possible arrangement of the particles and their energy in a given system. In other words, it is a measure of how disordered a system is. When a system becomes more disordered, it is very increase in the entropy. So again, its entropy will increase when a system becomes more disordered. I have one chemical reaction there. Here, H2O in solid, or we call it as ice cube. It will change into H2O liquid or normal water. I want you to think again. What do you think? Which one? What states of matter that you think have high entropy based on its definition and based on our previous discussion? You can relate it with the arrangement of the particle. What is the arrangement of solid? What is the arrangement of liquid? Yes, correct. Okay, let me show you the arrangement of particles. Here is the arrangement of solid particles. It's very close to each other, right? And if we relate with the previous discussion, we can say that it's very tidy. So that it has low entropy. And then compare with the liquid arrangement. Here, we have a distance. The distance is increased. So if we compare solid and liquid, the liquid is more disordered so that it have higher entropy. Okay, so that's for the simple chemical reaction. But you know, we have really a lot of chemical reaction. We can actually calculate how many entropy for that reaction. So you can use this formula to calculate the entropy changes. Okay, let's practice, guys. This is the formula for calculate the overall entropy. We name it with delta S system. You have to find sigma or the total of the delta S in product here after the arrow and minus sigma delta S in reactant here before the arrow. And if your reaction have coefficient, don't forget to involve it. So multiply it with the coefficient. And if you have the data, you can actually calculate how many delta S or how many entropy for that reaction. Okay, please calculate first. Find what is the delta S system for this reaction. Done? Okay, good. Here, let's discuss. Because of we have coefficient in front of the product, so multiply it by 2. 2 times 38.2 minus 2 times 32.6 plus 205. And then the result is minus 193.8 joule, Kelvin minus 1, mole minus 1. So this is the unit for entropy. Please don't forget to always write the unit after the numbers. Simple. That's how to find the entropy or the delta S for the reaction. How is it, everyone? Do you have a question? Okay, so if you still have a question or you're still confused, do not hesitate to ask me, or you can also leave the comment down below. Okay, so yes, only that's the lesson for today. Let's recite Hamdalah together to close our session. Alhamdulillah, Rabbil Alamin. Thank you so much, everyone, to stay tuned on this video. See you on my next video, everyone. Bye-bye. Assalamualaikum warahmatullahi wabarakatuh.